Hi, today we're going to be doing the distributive property. The distributive property is a tool that we will use as we explore algebra. It's a way that we're going to be implementing our knowledge of factoring to help us to do more complicated problems. The topic for today's lesson on page 44 of your interactive notebook, 44, is the distributive property. The essential question is, how can I use my knowledge of factoring to help with the distributive property? And this is Standard 6, Number Systems 4. And by the end of this lesson, you should be able to use the distributive property to rewrite expressions as the sum of two factors. Well, let's think about those words. The sum. Well, how do we get the sum? When we add two things together, when we add. And factors, what do we know about factors? Well, factors has to do with when we are multiplying. That's the two numbers that we multiply to get to the product. So that kind of gives us a hint as to what kind of math we're going to be using today. So what we want to look at here, guys, is we're going to be pulling out the common factor in an equation or an expression. So if you look at this kind of silly example, you'll notice I have this person purchased a cheeseburger and fries when they went to In-N-Out. This person purchased a cheeseburger and a milkshake when they went to In-N-Out. What is the common thing that they both have? This person, cheeseburger french fries. This person, cheeseburger milkshake. What's the same? Well, they both ordered a cheeseburger. So I could say that that would be the common factor between the two. It's the thing that's the common between them. So I could then theoretically pull that factor out and write it a slightly different way. So if you recall, I had told you prior that when you do multiplication, you could demonstrate multiplication by using the symbol that you've come to know very well, the multiplication symbol. You can also use the dot, like I oftentimes do, and as I've told you, we're going to be using more and more this year. And then another way is that you can write a number outside of parentheses, or a variable outside of parentheses. And anytime you have this number next to this parentheses, or a variable next to the parentheses, that means you're going to multiply by anything within the parentheses. So these are three different ways. You could also have a fourth, which is just putting the variable directly next to the number, which we'll use that when we get more into algebra as well. But for right now, we're going to focus on this way of demonstrating it with the number directly next to the parentheses. So if you'll notice here, what they did is they took the hamburger, and like I said, the common factor, they pulled that one out. And they said, okay, if I multiply, and I'm going to demonstrate this by putting it next to the parentheses, if I multiply this hamburger into the fries, I'm going to get a hamburger and fries. If I put this hamburger in with the milkshake, I'm going to get a milkshake and fries. But I'm going to write it in this way where I pull it out of these parentheses. So what you need to remember is you pull out the greatest common factor. So let's imagine now that we had, per se, if we had, like, this was an X, this was a Y. This is an X, this is a B. Okay? My X goes outside the parentheses, and then I would be left with my Y plus, because that's the operation I'm using, B. So I would have X times Y plus B. And that's how you could show this if you were to say it in an algebraic way. All right, well then let's practice this, okay? We are going to, if you look at the example that is given below, it says rewrite 27 plus 36 as the sum of two factors. Now, check this out. It says rewrite. It does not say solve. This is the one thing that everybody struggles with this. Your mind wants to solve it because it seems to make sense. And I can solve that. I can add 27 and 36. I could probably do it in my own mentally, in my brain. But that's not what it's asking. It's saying it's going to be written as the sum of two factors. You're just restating the problem. You are not solving it. Do not solve these problems unless it says to solve it. And I know it seems counterproductive because why are you doing all that work when you're not solving anything? Because later on, we're going to be using this, and it's going to become really important when we do expressions and equations. So for right now, just trust me and follow the process. All right, so the first thing we're going to do is we're going to find the greatest common factor between our two numbers, okay? Because we're going to rewrite 27 plus 36, and we want to rewrite it. So before we can do that, we're going to factor. So first thing, number one, factor. So 27, 36. This is going to use our trees. 27, two numbers that go into 27 are 9 and 3. 3 is a prime, 9's not. But 3 and 3 are. That one's done. 36. Let's go with our 3 family and let's do 3 and 12. 3 is a prime, 12 is not. 3 and 4, 3 is prime, 2 and 2. Done. All right, so now, if you recall, we take the numbers that are the same and we put them in the center of our Venn diagram. So I've got a 3 here and a 3 here. That's one that's the same. I've got a 3 here and a 3 here. Those two are the same. And I've got some 2s. They're not over here. And I got a 3 and it's not over here. So if I was to find the LCM, I could put those over here and I can multiply all those right across. But I'm not finding the least common multiple. Find the greatest common factor. So what I'm going to do is I'm going to, yes, I'll put these over here. I've got an extra 3, and I've got an extra 2 and a 2. But I don't need to really use those at this particular moment. What I need to do is I need to just look at the center of this Venn diagram, and I'm going to find the GCF. So number 2, find the GCF. So finding the GCF, I'm going to say 3 times 3 is 9. That's my GCF. So I'm now going to rewrite the equation, or the expression. It's an expression, not an equation, because there is no equal sign. If we had an equal sign, we would have an equation, but we don't, so it's just an expression at this point. So we're going to write our 9 first, okay? So write first the GCF. Then I'm going to do a parentheses. Now, my next thing is, check this out. I'm going to go over here to my number that's on this side of the Venn diagram. That's already figured out for me. It's a 3. And I'm going to write it down here. Now, another way to do this is you say, okay, 9 goes into 27 3 times. Once again, how many times does 9 go into 27? Well, it goes in 3 times. So don't forget, you put the GCF, parentheses, and then how many times the GCF goes into your first number. Here is my operation. I'm doing adding. So I'm going to write adding. And now I'm going to look at the second side of the Venn diagram. Okay, well, I've got a 2 and a 2. Well, let's multiply those together, okay? 2 times 2 is 4. And now let's check to see if that works. 9 goes into 36 4 times. It does work. So we know that whatever's going to be on this side of the Venn diagram is going to be multiplied together, and that's going to equal this side. Whatever is going to be on this side is going to be what's on this side, and this is your GCF. Once again, another way of doing this is you just say, okay, this is my original expression. A common, or the greatest common factor between both of these is 9. 9 goes into 27 3 times. Adding is my operation. 9 goes into 36 4 times. And like I said, we're not solving it. We're just rewriting it. And that's it. You're done. All right, let's go to page 43. On page 43, you'll notice that you have a couple examples. Let's just start the first one together, okay? You've got 12 and 18 as the sum of two factors. By the way, don't forget, when you got this journal page right here, today we're doing notes. Well, today, in our class, it is 10-9. we are writing notes. Now, if you're taking these notes on a different day, obviously you would put a different day, but these are when we're going to be revisiting. Remember, we talked about that last week. We're going to keep track and try to hit that magic number of 7 times revisiting these notes. Okay, going back to our example. 12 and 18. So we're going to try to write 12 plus 18 in a different way using the distributive property as the sum of 2 factors. Remember, we are not solving. We're going to first start off by factoring. 12 is, let's do 2 and 6. 2 is a prime, 6 is not, but now we're good. 18, let's do 9 and 2. Done. All right. Now, remember, the center of our diagram is going to be the 2 or the 3 or whatever that are the same. So we've got a 2 and a 2. There's a 2. We've got a 3 and a 3. 3. There's not a, oh, is there a 2 on the other side? Nope. Is there a 3? Nope. So we've got on this side just a 2 left over. And on this side just a 3 left over. All right. So now we're going to say, okay, I've got my greatest common factor is 2 times 3, 6. That's my GCF. So I'm going to have 6 parentheses. How many times does 6 go to 12? Well, it does go in 2 times. What is my operation? Adding. How many times does 6 go to 18? It goes 3 times. And there you go. You're done. Alright guys, so now you're going to try this one on your own, see how you do. If you have any questions, you can for sure go back and rewatch this video. You can ask for help. You can email me for help. You can also go to Khan Academy. There's some great videos that they have there as well. So I hope you have a wonderful day and try to hit that 7 revisits on this note. Talk to you later.